Hello everybody, and welcome to exercise 5 on page 7 of the workbook. Let's take a minute to read this question together. At t seconds, the speed of a particle traveling along a straight line is given by f of t equals 20 over 1 plus 4t squared meters per second. They'd like us to calculate the integral from 0 to 3 of f of t dt, and then to give a complete sentence interpretation of our answer. So there's essentially two things that we'd like to do here. We want to calculate an integral, and then we want to explain what it means. Okay? So let's focus on the calculation part first. We need to integrate the function 20 over 1 plus 4t squared. And before we do that, I'd like to sneak a peek at that list of common Calculus 1 integral formulas and see if we can find a formula that looks like it almost matches this formula. Okay, we're not going to find an exact match, but maybe we can find something similar. So 20 over 1 plus 4t squared. Do you see any formula on this list that looks similar to that? Okay, well, as you look down this list, 6 is probably the closest match that we can find. It kind of has a similar form to the function that we're looking at. One thing you might notice about 6, though, is that the x squared that's in the denominator has a 1 in front of it. X squared is 1x squared. Okay, and so kind of with that in mind, notice that if we go back to the function that we have and just rewrite it a little bit, we can rewrite it as 20 over 1 plus, and that 4t squared can be rewritten as 2t quantity squared. That suggests a possible u substitution here to get us started. So we're going to let u be the part in parentheses, the 2t. Okay, if we take the derivative of that, we're going to get, let's see, derivative of 2t is just 2 dt. Okay, and then if we get the dt by itself, we can just divide both sides by 2, and we're going to get du over 2 is equal to dt. Okay, so let's rewrite our integral. We're starting with the integral of 20 over 1 plus 2t squared with that rewriting that we did. Okay, integrating from 0 to 3 in this case. And let's see, if we do our substitutions, okay, limits are 0 and 3. I'm going to write t equals 0 and t equals 3 to remind us that our limits are t values and not u values. Okay, and looking at our integral, this 2t that we have down here, that is what we called u. So we'll rewrite this as 20 over 1 plus u squared. And then the dt, we can look at our work and see that dt is du over 2. Okay, notice that we don't have any t's left in our integral. We just have u's. That's a good sign. And we can do a little cancellation here. So 20 over 2, if we cancel those, we're going to get a 10. Okay, I'm going to take that 10 and just pull it outside of the integral. Okay, and notice that the integral that we have now, 1 over 1 plus u squared du, that looks like formula number 6 here. Okay, we've just got u's instead of x's. Formula 6 tells us, though, that if you integrate 1 over 1 plus x squared, you get the arctangent of x as your antiderivative. Okay, and so that means, we go back to our problem at hand, we're going to get an antiderivative of arctangent of u for this function. Okay, actually, I think I'd like to give myself a little more space here. Okay, and this is a definite integral. We've got limits of integration. So we'll put those in. And we're going to go ahead, now that we have an antiderivative, and substitute in our u. So u was 2t. So we're getting arctangent of 2t evaluated between 3 and 0. Okay. And so this is a definite integral. We're looking for a numerical answer. We are ready to plug in our limits of 0 and 3 and see what we get here. So we're going to get 10 arctangent of, if we plug in 3, we'll get 2 times 3 is 6, so 10 arctangent of 6. And plug in 0 for t, we're going to get arctangent of 0. Okay, at this point, this becomes a job for your calculator, but one question you might be asking yourself is, how do you use a calculator to calculate an arctangent? Okay, well, there is a key on your calculator for this. It looks like tangent inverse. So on your calculator, what you would punch in is the following: tangent inverse of 6 and tangent inverse of 0, okay, to get those two pieces here and here. All right, I'm going to go ahead and just show you what I got. I went ahead and punched this into my calculator and got approximately an answer of 14.1. Okay, so numerically, that is our answer. We have calculated this integral, but remember, they wanted us to actually interpret this as well. Okay, what does this integral mean in the context of this applied problem that we're doing? Okay, well, we can answer this question by thinking about units. So you think back to Calculus 1 for a minute. An integral was about finding area, basically. Okay, an area had two components, and you might remember looking at pictures of rectangles when you were talking about integration. Okay, so there's the height of your rectangle, which is like the first piece, and then there was the width. Okay, let's think about what the units of both of those are. So 20 over 1 plus 2t squared, that was this function we were given, and its units were in meters per second. It was representing speed. So I'm going to sneak those units in here. And then what unit is time being measured in our problem? They told us seconds. So in doing this integral, we're taking meters per second times seconds. What happens when you multiply those two units? Okay, the seconds are going to cancel because 1 second is in the denominator and the other is in the numerator, and we wind up with units of meters on this answer. Okay, so ask yourself, what are we measuring if our units are meters? We're really talking about position. Okay, so you can think of this 14.1 meters as telling us the change in position of the particle over this 3 seconds. Okay, let's write that down and then we're done with this problem. So our answer indicates that the particle's displacement over the first 3 seconds is 14.1 meters. Okay, and we're done.